streaming. We are live. Give me a second. But yeah, today we discuss Codeforces around 174. I solved it today, and I'll be sharing my solutions to everyone. So the question was, for an array A, we define its equality characteristic as the array B, which is bi equals 1 if the ith element of array A is equal to both of its neighbors. Basically over here it is equal to both of its neighbors, but over here it's not equal to both of its neighbors. So now the example is given that this is the A and this is the B. Now what you're given is B, you need to figure out if A is possible, like if an A is there such that this B exists. So like now the way I solved it was a bit complicated, the way the others solved it, and mostly you probably are very easy. So I'll just directly go to what you want to solve. So let's just take this example. Okay, it's a no. Why is it a no? Let's see. Okay, for this to be a 0, A has to be, for example, it is, let's say 0 0 1. Correct. It can be this, or it can be 0 1 1, or it can be 0 1 0. Good. All of these places where this index is not equal to both of its neighbors. Now when you get a 1, there is only one such string which is possible, which is this one. Like it can be 1 0 0 0 also, and many other numbers, but let's just assume it is this. Instead of 0 1 1, let's just do this 2 3 3 and then 3. So this matches, and when I get a 0, I have to choose something else. So let's say I choose 2 again. But now can I make this 1? For this 1 to be there, 2 has to be equal to 3, which is not possible. So if you just observe over here is, whenever I have a 1 0, I most probably should have a 0 again. 1 I shouldn't have. So I think everyone who just did 1 0 1 just passed. And sign in here. So everyone who did that just passed. But the way I did it very complicatedly. But in general, I'm just doing DP, the brute force DP, where I have I, previous, and cur. So based on these, I can kind of make sure कि you'll get the answer. So like, because I couldn't prove this 101 wala case for some reason at that time, so I thought of this DP states that basically I'm doing basically I can have two different starts, right? Starts can be both being same or one being different. Those are the two starts I can have. Now based on these two values, the third value kind of forces itself based on whether it's 0 or 1. So if I have previous and cur and AI equals 1, now previous and cur both have to be equal, or else I just return false. And here what I do is, if both are equal, I make sure this next value is also equal. So I pass on cur and I plus 1. Now if a of I is 0 and both are equal, the previous two are equal, then I have to have a different value here. So the next value is not cur, and if both are not equal, then I still have two options. cur and 1 and cur and 0. Whatever it is, I just choose. So that is there, and at the end I break out when it is n minus 2 because there are n minus 2 elements in A. This is basically B. I hadn't done this, so I got a WA, and when I get this, I get SC. Then this straightforward way is doing 101. So it's just I couldn't prove it, so yeah, that's it. Any doubts here? No, then let's just move on. Now in B, you're given a matrix. One, two, 1, 3, 1, 3, 2, 4, 1, 2, 2, 3, 4, 3, 2. Okay, that's it. This is my matrix. What it is saying is, I choose a subset of my numbers. Okay. I choose a set of strangers. Strangers is basically the ones which don't share a side, but all of them have the same color. And I paint them all to some other color. So what it's saying is, let's say I want to paint all colors with 2, like which are 2 with color 1. Let's say I want to paint these numbers, these elements to 1. Now they have to be strangers. Strangers meaning they shouldn't share a side. Over here, these two share a side, these two share a side, these two share a side. So if I don't take this and I take 1, 2, 3, 4, in one move I can paint all of these 1. So that was my that is my operation. So now I want, and at the end of the day I want to make all colors same. How do you do this? So basically, if you look right over here, if I want, let's say, all of them to be 1s, okay, I'll have to make 2, 1, 2, all the 2s 1, all the 3s 1, all the 4s 1. Correct. Now, how many operations will it take for me to make 2, 1? Okay. So that is, now my claim is that was either gonna be 1 or 2. Why is that? When is it 1? It is 1 when all 2s are strangers and 2 is otherwise else. Why is that the case? So let's say I have 2, 2, 2, 2, 2, okay, and then I have another 2 here, another 2 here, another 2 here. So now over here, if you see, these are not strangers. This is the entire thing. What I can do is, in one operation, I don't choose these. I choose everything else. They won't be strangers. Now in the next move, I can make sure that these two numbers are not strangers, because if I have not chosen this, all the ones which are not strangers, I choose it in the first operation itself. So then what does it make sure? Ki the next operation, all the numbers are going to be strangers. Does that make sense? If I am choosing in one operation, basically in 2 operations, I can make any number to any number at max 2. 1 is also possible. 1 is when there are no strangers. So that is there. But now 3 ke liye, so now in this question, in this matrix, let's see. If I want to change 1 to anything else, it will take me 2 operations. Why? Because these two are not strangers. For 2 also it's gonna take me 2 operations. For 3 it's gonna take me 1 operation. And for 4 it's gonna take me 1 operation. Now when I know this, isn't it better for me to make 4 into a 1 instead ki I make 1 into a 4 and 2 into 4? I'll take more operations if I make all of them equal to 3, right? So what you do is, after you get this map, you can just sort it and not take this into your answer. Your answer can be addition of all these, basically 2 plus 1 plus 1. So that is what you do. Now how do you calculate strangers and not strangers? You can just directly brute force check. So coming to the code for B. So I take the input. Firstly, I set all the unique colors to 1 because minimum सबको one change तो लगेगा. Now each color will take at least one move to change to a different color. Now what am I doing over here is, I'll just zoom in so you can see clearly. So now for every I comma j, I check its adjacent move. So what is this move vector doing? Basically, it's a very fine way of checking all the 4 adjacent cells. That's it. So you just basically, if you do this, if you run this loop, the x and y will be all the 4 adjacent cells. Now if any adjacent cell is equal, I set that color to be 2, because if any cell is equal, I'll take minimum 2 operations, like maximum I'll take 2 operations. So that's it. Then I have this map which has either 1 or 2. I store the operations in a vector, I sort it, and I don't include the last value. Oh wait, I think it just cut out. And then at the end I print out answer. I take the sum and I print out the answer. Is this clear? Yes, no. Cool, I guess that's clear. Moving on to C. Okay. So now sequence is called beautiful if the following conditions hold. Its length is at least 3. Every element except for the first one, there is an element to the left which is less than it, an element to the right, and every element except the last one, an element to the right which is larger than it. So over here, 4 has a 1 before it and a 7 ahead of it. 2 has a 1 before it, 7 ahead of it. 4 has a 1 before it, 7 ahead of it. 1 has a 7 ahead of it, 7 has a 1 before of it. So that is how this is beautiful. While over here, 2 doesn't have something lesser before it. 3 doesn't have something greater after it. So that is the cases. Now given an integer array of size n with only 1, 2 or 3, your task is to calculate the number of beautiful subsequences. Now, when I only have 1, 2 and 3, what are the only subsequences I can make? Let's say my first element is 1, my last element is 2. What numbers can I put in the middle? I can't put any. Why? Because if I put a 2 here, to the right it won't be greater. If I put a 1 here, put to a left, it won't be lesser. If I put a 3 here, to the right, it won't be greater. So starting from a 1, it can't end at a 2. That is sure. Let's say I end at a 1 also. Same thing, 1, 2, 3, both don't satisfy. This is also not valid. So starting at a 1, I can have a 3 over here. What can be in the middle? Can I place a 1 here? No. Can I place a 2 here? Yes. Can I place a 3 here? No. So now basically it all boils down to 1, some 2s and 3. These are the only subsequences which are beautiful. Beautiful, right? Huh. Only subsequences which are beautiful. So now we need to figure out all the number of beautiful subsequences in an array. Now, if the constraints were smaller, let's say it was 1000 only, and to be 1000. So what is the easiest way to do this? I can just, for every 1 and 3, I can find what is the number of 2's in the middle. Let's say there are x number of 2's in the middle. My answer will be, I'll add 2 raised to x minus 1. Why is that? Basically, let's say I have 2 3's over here, 2 2's here, and 1 and 3. Okay. Now, for anything to be in a part of a subsequence, this has two choices: it existing and it not existing. Each of them have two choices: it existing, it not existing, it existing, it not existing inside the subsequence. So total, how many possible combinations are there? 2 raised to n, 2 raised to x. But now, one thing to make sure is this condition, that the length is at least 3. So there should be at least 1 2 in the middle. That is why I subtract 1. This 1 is basically all zeros. So now this is the thing. So basically if I basically do for every 1 comma 3, I figure out how many 2's are in the middle, I can answer very easily. So now how do I do it otherwise? So because now n square doesn't work, I have to do it in O of n. So now this is where, wherever these type of questions come in, where you need to figure out all number of subsequences and stuff, it's more or less always the contribution method. In how many subsequences will a particular element occur in. So now, what type of contribution do we work in this question? And now you might think, starting at a 1, let's see how many subsequences are there, good subsequences are there. But starting at a 1, it depends on the ending 3. So you can't basically, like, if I fix starting 1, it depends on ending 3's, and this can be O of n. So this basically you can't do. Same logic works for 3, so 3 also you can't do. So then by method of elimination, you kind of come up with कि I need to figure out how many subsequences a 2 will be a part of. So that is how you just like kind of come up to the, like basically come up to the conclusion that I have to do contribution technique on 2's, but still the question is not over. So for example, I have this 2. How do I calculate? Its contribution? Because technically, the answer is 2 raised to x minus 1. Now, how do I know how many 2's are there between 1 and a 3? So that is where the problem occurs, right? So now, and like, no wait, this is like 3 also, it is not. Kind of the actual approach is we are combining this and a 3. And at the end of the day, you figure out, wait, my argument was wrong. 3 ka, okay, don't worry. Now in this 2, it depends on this value, 2 raised to x minus 1 between 1 and 3. How do I know कि this 2 how many times will occur? So kind of you can basically omit this. Now what you're left with is number of subsequences ending at a 3. So now this, if you can do, you will solve the problem. So now let's say I have 1, 2, 2, 1, 2, 2, 3, okay? And then another 3. For this 3, how many subsequences are there? Now if I do it manually, it is basically 2 raised to 4 minus 1 plus 2 raised to 2 minus 1. What is this minus 1? Minus 1, if I just combine it, it is 2 raised to 4 plus 2 raised to 2 minus number of ones. One before. So that is cool. Now how do I figure this out? How do I figure 2 raised to 4 plus 2 raised to 2? Now, if you see, now let's see the plan beforehand, okay? Now I need to do something so that when I come up over here, I just directly get the answer. I directly get this value, which is what? 16 plus 4, which is 20. How do I get this? So now, if like the way I came up with, I just happened like now over here I was thinking some lazy propagation, some kind of segment tree. So what, like basically if I have ones and if I get a 2, I need to add a 2 to the power, right, to both of them. Okay. So basically this will be x plus 1, this will be x plus 1. So that when I get a 3, I can do 2 raised to x plus 1, like this is y. Okay. So my answer will be 2 raised to x plus 1 into 2 raised to plus 2 raised to y plus 1 minus 2 for this 3, for this particular thing. So now how, like technically even like segment travel, like there must be something simpler. Even segment tree gets pretty fuzzy. So now if you see, let's say I have 2 raised to x plus 2 raised to y. Now when I add a 2 over here, I'm doing this, okay? I'm doing some operation such that this becomes 2 raised to x plus 1 plus 2 raised to y plus 1. If I just take this, is not only, this is just equal to 2 into 2 raised to x plus 2 raised to y. So what do you see? If I find a 2, I just multiply this entire thing by 2. Correct? Does that make sense? Hello. So yeah. So now the thing is, now if I find a 2, multiply my subsequences by 2. If I find a 3, I just add the subsequences to answer. Now what is happening at a 1? What do I do if I find a 1? So this is where, if you see, if both of them were 2 raised to 0 plus 2 raised to 0, basically 1 1 and then a 2, they'll become 2 raised to 1 and 2 raised to 1. So what I can do is I can just add a 2 raised to 0, which is just add 1 to subsequences. That's it. This is the entire logic, and you just do that for the entire app. So coming to the code, whenever it is something like mod, it is better to use a mod template. Why is that so? Because then you can just do normal operations and forget about taking mod. So this mod template, it is there in, if you just search capital GitHub, it'll be first thing there, and you will find it in content, number theory, and modular arithmetic. This is there. You'll also need to add this part, which is Euclid function. But yeah. So if you just do this, it'll be helpful for you. So then what I'm doing, I'm just using the algorithm straight up. Earlier my answer is 0, and my current subsequences is 0, and number of ones is 0, because at the end of the day, oh wait, yeah, and I also have to do minus number of ones. So this is that. Now whenever I find a 1, I increase count of 1, I increase current. Whenever I find a 2, I multiply by 2, and whenever I find a 3, I add current and subtract 1. That's it. And at the end of the day, I print answer. That's it. So that is C.
Can you tell about if you find a 2, that part again?
Okay, yeah.
Uh,
So now if I have, let's say, some ones beforehand, and I have a 2 over here. Okay. Basically what I'm denoting is, let's say I have a 3 over here. This. In this 1, I'll store how many 2's are there after this 1. Okay. So there are 1, 2, 3. If I'm like basically, if I just compute till here, so what is this? I'll have 3 over here, 2 over here, and 1 over here. Correct? There are 3 2's after it, there are 2 2's after it, 1 2 after it. Does that make sense? Hello?
yes.
Huh. Now when I'm adding a 2 over here, what do I need to do? I need to add 1 over here, add 1 over here, and add 1 over here. Correct?
Yes, yes.
Huh. But my answer is like, and my answer is gonna be 2 raised to x plus 2 raised to y plus 2 raised to z minus 3. Correct? Because there are 3 ones before this 3. Okay.
Okay, yes.
Huh. So now what is the change in this power? I'm adding 1 here, adding 1 here, adding 1 here. I'm adding 1 in every single place. Correct?
Yes.
So now if I'm adding 1 over here, can't I just take 2 common? And it becomes what? 2 raised to x plus 2 raised to y plus 2 raised to z. Basically, instead of adding 1 in every single power, I multiply with
Multiply
2
by 2.
for
Yeah, that's the
every
same thing.
number.
Got
Yes, same thing. Exactly.
got it. Yeah.
So that is I'm multiplying by 2. And when I'm adding a 1, that is basically me adding 2 raised to 0. Because there is no 2 ahead of it, but that is a 1 there. So that is that. So that is I'm doing cur plus 1 and 1's plus 1. And finally answer to we had derived earlier. So that is D, that is C. Moving on to D. Yeah, okay. So now, you're given an S. You can perform the following operation in the string S. You choose a consecutive string and shuffle it. Make it as per you wish, like whatever order you want. Now you need to figure out, you can do this operation only once. Now you need to figure out what is the minimum possible length of the substring, on which if you perform this operation, the string becomes a palindrome. A palindrome is basically, if you reverse the string, is the same. Now some key things to note: S has an even length. S can always be converted to a palindrome, and sum of length S over all test cases doesn't exceed 2 if. So now if I have some random string A B C D E F, A B C D E F. Okay, this is a random string. This now what is a, like, can I always make it like a palindrome? Like, let's say, like, it's given, I can always make it a palindrome. What is the maximum, like, what can I do? Easiest thing is, I take this entire string as a substring and I shuffle it and make it a palindrome. Correct? That is the worst case. I take the entire string. Now, obviously, I don't need to do that. I need to print the minimum substring, minimum length of the substring, right? So now this is where the kind of logic comes in. So now, let's say, like, since it's an even length, there'll be a split point. There'll be a split over here, such that these both have n by 2 characters. Why is this important? So now let's say all characters in left are there in right. Like, basically, if I do for all character in left, frequency in left is less than equal to frequency in right. Okay. If that is the case, why am I doing this? If that is the case, can't I just ignore one half of it? Like, for example, over here, these two have, like, basically same. If I just take this string and do, like, shuffle it so that it matches this part, it works, right? Yes, no.
Instead of taking the whole part, like we can find the first and last of the like unmatched places in the palindrome.
Yeah, you can do first and last unmatched places also. But yeah, I'll come to
From
that
both
a
of
bit
the
later.
sides, we can find the minimum one.
Huh. I like the way I code it, the way I thought of it. That part comes a bit later. So, like, one thing, like, first thing I'm doing is I'm reducing my answer to as minimum as possible. Okay. So what I'm doing is over here is, if I find a split point such that either frequency in left is less than equal to frequency in right, or it is like this, or it is ulta, like frequency in right is less than equal to frequency in left. Once I get this split point, I can just ignore the smaller half. Why do I ignore the smaller half? Because I can just shuffle it so that it matches the smaller half, correct? Like, for example, here,
Yes.
if I split over here, both are same, I can just do operations in this string itself and I can mirror, right? So that is the
Yes.
first thing to note. Okay, now what if the split point is like, what if the split point is not in the middle? Let's say it is A, B, C, C, D, E, F, A, B, D, E, F. Okay. Firstly, the split point should be in the middle. 1, 2, 3, 4, like, should be over here. But now here, C ka count is greater over here, and F ka count is greater over here. So this split is not good. What else split can I do? Let's try this split. Same thing, C ka count and F ka count don't match. This split, C ka count and F ka count don't match. This split works. Okay, because over here, all correct, like A
We
ka
need
there's
to check
1
for
1, B
each
ka 1
and
1,
every
C ka 1.
character.
Huh?
Each and every character का हमें split देखना पड़ेगा.
No, each and every, like, split basically makes sure ki this, for each character, the smaller portion has the frequency lesser. Like, if you don't talk about left, you talk about small, frequency in larger. So this is just 20 of 26 check. Correct?
हाँ.
Huh. So now I can kind of, like, basically iterate, right? एक एक करके. And then I can get this split point, right? This is one of the split point. There's one more split point. What if instead of going to the left, I go to the right? If I do this, this split is valid because A का frequency 1 1, B का frequency 1 1, D का frequency 1 1, E का frequency 1 1, F का frequency 1 1.
सी
तो
का
perfect.
तो 2-0 हो गया ना,
हाँ, but
2-0 हो गया सी।
इसका 0 है ना, 0 is less than 2. This part is smaller.
हाँ
हाँ, तो that is why smaller less than equal to right larger. So since C का frequency is 0, it's valid, right?
या
Why am I doing this? It is because then I can just ignore this part. I can do something over here only. Does that make sense? Basically, if I just rearrange this, for example, I can make it F D F E D B A C C, and then this part, which is A B D E F, remains the same. So now if you see, match, 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 and match, magic. So this
we
is why
can
the
just
split
only
point is
ignore,
important.
like
Huh?
the split point is not the exactly middle point.
Split point is not the middle
That
point,
case,
but it is the point where the smaller portion is completely within the larger portion.
मिडल पॉइंट में तो वर्क नहीं करेगा ना।
हाँ, हर बार मिडिल पॉइंट पे नहीं होगा. देर माइट बी द केस वेर मिडिल पॉइंट हो सकता है. फॉर एग्जाम्पल हियर मिडिल पॉइंट पे भी हो सकता है ना. सो दैट इज आई कॉल इट अ स्प्लिट.
नहीं नहीं, अगर लाइक मिडल पॉइंट में एक का फ्रीक्वेंसी ज्यादा है दूसरे का
हाँ
कम है, लाइक 2-0 वाला केस, ये वर्क नहीं करेगा।
हाँ, इसमें वर्क नहीं करेगा. दैट इज वेर यू डू इधर यू शिफ्ट टूवर्ड्स द राइट और यू शिफ्ट टूवर्ड्स द लेफ्ट. राइट और लेफ्ट, वॉट एवर यू वॉन्ट. So over here there can be two valid split points. What are the valid split points? Either here or here. Works?
True.
Huh. So now if I let's say consider this split point. Let's take a better example. थोड़ा सा A B C D and then FF. Blah blah blah. C 1 2 3 4. I want the midpoint over here. C C D C D. Ah. C. Wait. Wait. क्या था? I noted down an example. I'll just use that only. A C B D D A C A C D C. Okay. 1 2 3 4 5 6. I think the split point was originally over here. Okay. So now if I shift it towards the left, my split point comes up here. Here basically this is the point where every character the frequency is lesser than the right. Okay. Now can I reduce this further? That is my question. Firstly तो इतना तो मुझे like I'll have to shuffle this part out at least इसको मुझे someplace where else जाना, like I'll have to put it somewhere else, right? I'll have to put it in the fourth place basically here. Correct? At least this D, because that is where the split point is occurring. Yes, no?
Yes.
So now this part though I'll have to maintain, like some substring starting from here I'll have to shuffle. But now this pura, let's say this, I take this pura substring. Can I reduce this substring? Over here these two are matching, right? So I can reduce this part. These two are matching, I can reduce. BB are matching, I can reduce. Now I can have this string in which I can for sure say कि I'll have to at least do इतना shuffling. Correct?
वो तो तुमने देखा कि लास्ट के मैच हो रहे, व्हाट इफ ये जो DAC है ये मैच हो जाए।
हाँ. So that is like हाँ. These are the last वाला. अभी first वाला matching की बात करते हैं. स्प्लिट पॉइंट का कंडीशन व्हेन इट अकर्स इज कि दिस इज द प्लेस वेयर ये दोनों लाइक काइंड ऑफ लाइक अभी हियर डी डी आर मैचिंग राइट बट द प्रॉब्लम इज सिंस दिस पार्ट इज लेसर this D has to be shifted somewhere ahead. Correct? So I can't reduce this part, right? If I take it like this, I take AC only. तो still DD का प्रॉब्लम तो एग्जिस्ट करेगा ही ना.
DAC ले लेते तो
DAC लेते हैं तो फिर सेम थिंग ना. अभी C एंड D डोंट मैच. मैं इसके अंदर कितना भी सफलिंग करूँ, C and D if they don't match, they're not going to match anywhere else, right? So that is why DACC is the minimum thing. Like basically, left say I can reduce, like the left say I can reduce, or right say I can reduce, left say I can't because like wherever the split point is, if like I can just prove it like this, okay, right? Split point is a place where this character is the one which skews this, right? Like this character makes every character here equal in this.
True.
अगर मैं इधर split point लेता, like if that was not the case, then the split point would have been here, right? तो ये जो the last character है जो split point की वजह से shift हुआ है, उसको तो मुझे स्विच करना ही पड़ेगा. That is a given. So now left is fixed. Only thing I can do is I can change the right. Right कैसे चेंज कर सकता है? I check the matching part. ठीक है? Works.
एट द एंड जहाँ पे मैच नहीं हो रहा है वो उधर से लेके तुम्हारा स्प्लिट पॉइंट तक वाला लेंथ होगा.
हाँ, उतना लेंथ मुझे करना पड़ेगा. That is my answer. Now, but yeah, that is where the other thing comes in. There was another split point, right? Wait. Over here, what is the answer? DACAC, which is 5. Correct? Now, what was the other split point? The other split point can be over here. This split point. Basically, A has 2, C has 2, C has 2, B has 1, B has 1. Perfect. So this is another split point. Now let's do the same thing. Match. Itna part is not matching,
4.
correct? Now my answer is 4. I just take the minimum of both. Make sense?
अच्छा, तो हमें मल्टीपल जो अगर सेम स्प्लिट पॉइंट्स मिल रहे हैं तो उन सब का मिनिमम निकालना पड़ेगा.
हाँ, मतलब एट मोस्ट दो स्प्लिट पॉइंट होंगे.
उससे ज़्यादा नहीं हो सकता.
नहीं, उसके ज़्यादा लाइक हो सकता है. फॉर एग्जांपल, बट लाइक मैं इधर भी स्प्लिट पॉइंट डाल सकता हूँ, सेम थिंग. बट इज इट बेटर अगर मैं ये वाला स्प्लिट पॉइंट रखूँ कि मेरा आंसर इससे कम हो रहा है ना. दिस स्प्लिट पॉइंट इज यूजलेस फॉर मी after I've calculated for this split point. हाँ, बेसिकली लाइक इतना मेरा मैक्सिमम मेरा रिड्यूस हो रहा है. इसके आगे अगर करूँ तो मेरा बेसिकली DACA हो जाएगा. एक और कैरेक्टर ऐड हो जाएगा मेरे मिनिमम में, विच वी डोंट
तो
वांट.
अगर जब राइट साइड मूव हो रहे हैं तो फर्स्ट स्प्लिट पॉइंट लेना इज अ बेटर थिंग.
हाँ, फर्स्ट स्प्लिट पॉइंट एनी प्लेस यू लेफ्ट
और
और
लेफ्ट साइड में भी
फर्स्ट स्प्लिट.
ओके, हाँ चलिए.
हाँ. So now this is the case where I move left and right. What if it is something like this? इधर तो मैंने मूव किया नहीं है. Wait, let's take a better example. ABC, CA, D, CA, CBA. Wait, इधर D also. Here this split point is valid because D11, C22, A22, B22. Perfect. Right? This is where I haven't moved the split point. वो बीचों बीच ही रहा है. In this case, can I reduce from the right also?
हाँ राइट से कर सकते हैं.
हाँ, इसमें राइट
राइट
से भी
एंड
कर सकते हैं, लेफ्ट से भी कर सकते हैं. यू कैन रिड्यूस फ्रॉम बोथ एंड. So that is a special case, that's it. Then you have solved the problem. So coming to the code, firstly I assume the split is in the middle. फिर I'll calculate left and right का frequency अरे. Simple. Now this is my check function which I call every single time. Check function has a small vector and a large vector. Okay, large, smaller string and larger string. Now I just return false where smaller is greater than large. Simple. Now firstly I check कि midpoint ही correct है. Then what do? I reduce from the
लेफ्ट और राइट से
ends
reduce.
and बीच में से. So मैं क्या इधर क्या कर रहा हूँ? This is these 2 points and I go in. So this is where it will fail. So my answer will get reduced by 3. पहले तो my answer is gonna be n by 2, worst case. Because split point इधर है, at least मैं इन सबको मैच कर लूँ. Now when I'm moving the pointer, I'm reducing my answer. Right? So answer minus minus. While it is equal and I less than j. Simple. Now one base case, अगर answer 0 हो गया तो print 0.
पैलिंड्रोम वाला.
हाँ, palindrome. Or else अभी मुझे बीच में से भी I'll have to remove commons. So these are the 2 midpoints, and I minus minus j plus plus, same thing, answer minus minus. Okay, I print the answer. Fair. Now this is where I do split right, move the split right and move the split left. Firstly
जहाँ
I'll
पे अगर स्मॉलर वाला मिल जाए वहाँ पे ब्रेक कर दे रहे हो तुम.
हाँ, so now basically midpoint लिया मैं, like now here, so let's say I am here. Okay, okay. हाँ, so ये रुको, ये तो गंदा वाला केस था. किधर गया डी. हाँ, ये वाला केस. हाँ, so now n by 2 is this point, n by 2 is this index. Okay, तो अगर मैं shift right कर रहा हूँ तो starting from n by 2, I include this in left and I remove this from right. Include this in left, remove this from right, and I increase the split point. Firstly it was at n by 2, now it is at n by 2 plus 1. Okay, and I break where the check condition holds. Simple. Now what is my answer? Let's say I have a split over here. Split point is over here now. My answer is this index itself. 1, 2, 3, 4, 5, 6, 7, 8. 8 total. जो भी split होगा, since split points to over here, it's gonna be, answer is gonna be at max that much. और फिर माइनस माइनस जो एंड से करते हैं.
हाँ समझ गया.
सेम थिंग अभी स्प्लिट 2 आ गया. स्प्लिट 2 वंस अगेन n by 2 पे है, स्टार्टिंग एट n by 2 minus 1. सो ओवर हियर आई रिड्यूस. नाउ आई इंक्लूड दिस वैल्यू इनटू राइट में ऐड, लेफ्ट में सब्ट्रैक्ट, एंड स्प्लिट 2 को भी सब्ट्रैक्ट बिकॉज इट्स गोइंग टुवर्ड्स द लेफ्ट. Now same thing check, but now my answer is going to be n minus split 2. Same thing, you can also do add and do split 2, but just work. This is just,
But yeah,
huh, this is like, if you look at the logic, you're just doing that only. So that is why I did n minus split. And then same thing, n se nikalo, and then you print out the minimum. That's it.
yeah.
Cool. So yeah, that is the PCD. E I couldn't solve. I have approaches, but at the end couldn't solve. So will upsolve. You'll also, for you guys also do upsolve if you haven't solved any question. See you in
I
the
will
next contest.
solve
Bye bye.
D&D.